Hello math nerds, this is video 10, the final unit circle video. Dun dun dun! And today we're going to try to tackle over rotation, negative thetas, and reciprocal functions. And you may not know what some of that means. That's okay, we'll figure that out. That's why we're here, right? Yeah, there you go. Alright, so what does it mean to have a negative theta? That's what we call going backwards, or yeah, I call that going backwards, because normally in a unit circle you go counterclockwise, you go that way, but now we're going to start at 0 and go backwards. So if I want to find the cosine of negative pi thirds, what I have to do is travel to that place on the circle. So I have to go, let me move this, my unit circle's underneath. So the distance from here to here, that whole length of the arc, remember how we talked about that's the arc, that whole distance is positive pi thirds. I have to go that same distance backwards. And wherever I land, whatever the answer is, whatever we're asked cosine, whatever the cosine of where I land is, that's the answer to my question. Okay? And look, I landed on a pi thirds guy. You know, it has a 3 for a denominator. That's crazy. So if it's cosine, I'm looking for the x value, so it's 1/2. So that's my answer. Wow, that's pretty cool. Huh. So let's go negative 7 pi 6. So what that means is I have to go 1 pi and pi 6 more. So let me look at that again. Hold on a minute. Sorry, I took that away a little too fast. I gotta make a plan before I start moving. So 7 pi 6, you know, 6 goes into 7 one time. So that's 1 pi and 1 left over. So really, I'm thinking about it like this. Here's my thinking cloud, you know me. So I'm really thinking that is pi and pi 6. Like that's breaking that up because I can kind of figure out how to move that way. But I'm going backwards. Okay, so I got to travel this much and see where I land. So here I go. Dun, 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 dun. Here, start at 0. Dun, 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 dun. Here we go. Woohoo! I've hit pi. Now I go one more pi 6, and there I land, right there. So whatever the answer for that, oh my goodness, look, I landed on a pi 6. Huh, I wonder if that happens every time. Huh. So it said to find the sine of that, and the sine is a y value, so it's 1/2. And I didn't do that on purpose. The first answer was 1/2. All right. Huh, that's really interesting. Wonder if I land on that every time. Boy, that sure would make it easier, wouldn't it? And then this one asks you for the tangent of negative 3 pi 4. So I have to travel backwards 3 pi 4, that distance. Wherever I land, I got to find the tangent of that person. Okay, man, I hope I land on a 4 because you know we love the tangent of the 4. So here we go. So if I went from here all the way to here, that would be pi. But it said 3 pi 4, so I can't go all the way to there. So I need to go land on that guy. That's 3 pi 4s. If you don't like that, what you can do is think, okay, I need to go that distance. See, that's 3 pi 4s, but backwards. And that'll make you land right there at 5 pi 4s. My little sheet keeps moving, sorry. So it seems to me that we keep landing on the same denominators we're traveling. And that actually will happen as long as your fraction is reduced. As long as you have a fully reduced fraction, you will always land on that same denominator. So actually right now, I know that the answer to this is part of it is 1. And I've just got to figure out what the value, like positive or negative it is. And when we went back 3 pi 4s, we landed there. And that is left and down. And a negative over a negative is a positive. So wow, that's kind of nice. So all the things that I learned before, because it's going to have the same value as where you land. So it's everything that we've done. We've just got to figure out where we land when we move. And then we apply the things we already know. That is crazy. Okay, I want to do a little picture of this while I'm here. Negative 7 pi 6, we landed there, right? And negative pi third, we landed there. All right. So So what is number 4 all about? Okay, number 4 is 17 pi over 6. That's way over 2. So what you have to do with this one is you have to think about it. Okay, so how many times will 6 go into 17? Well, I think 6 times 3 is 18, so not that many. So 2, I think. So that's 2 pi plus, and then how many are left over? Well, 2 times 6 is 12, so there's 5 left from that, right? So there's a 5 pi 6 left. So to find out what the sign of this guy is, I've just got to keep going around the circle. I know, crazy, right? So I've got to go 2 pi, and then I've got to go 5 pi 6 more. Wherever I land, the sign of that, where I land, is the sign of 17 pi 6 as well. So here we go. Dun, dun, dun. I know it comes with music. It's crazy. So start at 0. Now we're going back the right way because this is a positive, not a negative. So dun, 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 dun. 2 pi, there's 1. And then a 5 pi 6 more makes me land right there. So I'm going to land on 5 pi 6. And so this 17 pi 6 has the same question as sine of 5 pi 6 because that's where I landed. Okay, so for 5 pi 6, let's just think about it. 5 pi 6 is that real small sliver, right? So it's like right there, and it's over a lot, up a little. So up a little, up a little. There you go. There's your answer. So once you figure out where you land, you use everything we've done before. It's not really new. You've just got to move more around it. How do you go 5 pi? Well, I don't know. Let's see. Let me just grab my unit circle. We'll look. So here's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So I land right there. So what is the tangent of 5 pi? Well, it's sine over cosine, or y over x, right? So to get to that place in the circle, you go over there, you go over 1, left 1, and up nothing. So I believe that gives us 0. Right? Okay. That wasn't hard. It was just kind of weird, but we can do it. And then cosine of 11 pi over 2, Lord of mercy. So 2 goes into 11. How many times? Let's see, 5, I think. 5 pi. And then there's 1 left over, and that's, so I need to go another pi halves. So once I go to 5 pi, I need to go another pi halves. Are we ready? Okay, here we go. All right, so wait a minute. Didn't I just go 5 pi? Yeah. Oh, you know what? I noticed something. Look at this. 0, 1, I'm talking about the number of pi's, 2, 3, 4, 5, 6 pi, 7 pi, 8 pi, 9 pi. What do you notice? Yeah? So every time we're over here, we hit an even pi, and every time we hit over here, we hit an odd pi. So if I have 5 pi plus pi halves, I can really just kind of go, well, I know if I went 5 pi around, I would end up here. And then from there, let's go another pi halves. That puts us down here at 270. So I'm down here, right? That's really what I'm doing. And the cosine of this, if you start in the middle, you do not move left or right, it is 0. Because cosine's x movement, right? So there you go. So that is negative and over rotation. So negative means go clockwise. Wherever you land, you find the sine, cosine, or tangent of that wherever you landed. And for over rotation, you just have to figure out how to get there. Once you do, you just do all of the sine, cosine, and tangent things we did before. Okay, I know this is going a little quickly, but I know you're excited to learn the last of this, aren't you? All right, so let's talk about the reciprocal functions. So I know that cotangent is 1 over tangent. That's easy for me. But I get really confused with secant and cosecant. So this is how I figured it out. Secant does not go with the function that starts with an s. it goes with a function that starts with a c. So secant is 1 over cosine. And I know that may sound silly to a lot of y'all, but I used to get that mixed up really badly. And I was like, I've got to stop this. Okay? Cosecant is 1 over sine. So the c and s go together in the reciprocal world. And tangent, I could write 1 over tangent, but you know, tangent is sine over cosine. So cotangent is cosine over sine if you ever need that. Well, that means that for us to find values of reciprocal functions, we've got to flip all these people that we've been talking about for sine and cosine, right? Yes, Lord. So, here are all the values we said we're ever going to use in this circle, right? So let's flip all of those. So this is sine and cosine values. And these are reciprocal values. So if I put, oh no, that's really bad, isn't it? So I can get 1 over 0, which we're going to say is undefined. If you flip 1/2, you get 2. If you flip root 2 over 2, you get 2 over root 2. And if you rationalize by multiplying by the magic 1, you get 2 root 2 over 2, which is simply just root 2. If you flip this guy, sorry, I did not manage that space well, then you get 2 over root 3. If you rationalize by multiplying by the magic 1, then you get 2 root 3 over 3. And if you flip 1, well, you get 1. So if you get a secant or cosecant, the only values that you're going to be dealing with is undefined, 2, root 2, 2 root 3 over 3, or 1. That's it. So if sine and cosine only have 1, 2, 3, 4, 5 answers, then secant and cosecant only have those flipped 5 answers. Okay? So this takes a little bit more thinking on my part, so please forgive me. So I have to think about this. So secant of 5 pi 6 is 1 over cosine of 5 pi 6. And I know that pi 6 is that triangle. I got to really think about this. I have to slow down when I do this. Sorry, y'all. All right, that's the little triangle, right? That's over a lot, over cosine a lot. So over a lot is that root 3 over 2. So if I'm doing 1 over that, I'm going to end up with 2 root 3 over 3. Oh, sorry, I didn't draw 5 pi 6. I drew pi 6, sorry. 5 pi 6 is actually over here. I'm so sorry about that. I was just drawing the, we call it the reference triangle. Sorry about that. So there is 5 pi 6. So I know I go left to get there, so that's negative 2 root 3 over 3. Okay? All right. Let's do cosecant. And I got to tell you, these are a little harder. You probably want to take your time just a little bit on these. And that's okay. You'll have sine and cosine down. They don't ask you these as much. Oh no, but I love this one, right? We know that all pi fourths, no matter sine or cosine or whatever, is root 2 over 2. And when we flipped it, we got root 2. So I know that part of the answer is root 2 to this, right? Because if you flip it, you know, sine and cosine are the same, it doesn't matter. So secant and cosecant of 5 pi fourths would be partially root 2. I got to figure out where it is, though. So that is, let's see, that's 1 pi, it's that guy. And so I go left and down, and this is 1 over sine, so that's down, so that's negative. All right, cotangent of, oh Lord, okay. Cotangent of 5 pi thirds is going to be 1 over tangent. And you know how we said that tangent of all the 3's was the little 3 by itself, the root 3? Well, now it's going to be 1 over that because we know that. And if you rationalize that, I got to put the sign with it too. Sorry, I got to do that last. It's root 3 over 3. Oh my gosh, guess what? That is, oh my gosh. I'm going to have to write that in just a minute. But that's the other guy. That's the tangent of pi 6. So the cotangent of the thirds is the tangent of the pi 6's. You know why? Because that's that triangle swap thing. They switch sides. That kind of makes sense. But is it positive or negative? So 5 pi thirds is almost a 2, so that's down there. So that's right and down. So positive over negative is negative. So it is a negative. Okay, that's really cool. So if you know tangent of pi thirds, then that is cotangent of pi 6. Do I need to write that down? Probably for me too, yeah. Let me see what I'm saying here. So, so we knew that tangent of pi thirds, can you see that? Yeah, is equal to the root 3. Well, that means cotangent of pi 6 is equal to root 3 because they swap. And if tangent of pi 6 is equal to root 3 over 3, then cotangent of pi thirds is equal to root 3 over 3. Ha ha. Isn't that neat? You just flip them around. And guess what? Tangent of pi fourths and cotangent of pi fourths, doesn't matter, is 1 no matter what. And then, you just go find out where it is and give it positive or negative. But that's always going to happen. That is crazy. And then the zeros and undefines will swap too. Wow, that is so fun. The things you learn about the unit circle. So when you get a negative theta, just be careful. Go around the clock the right way. Wherever you land, find that trig function. To over-rotate, if you'll break it down and do the division, it's a lot easier to find out where you land. If it's an even pi like that, then, well, actually it's odd. Odd pi's land on pi. Even pi's land on 0 or 2 pi. And then if you'll break it down, it'll make it easier to find. Once you find it, then answer the question of wherever you find. Well, I hope that's been helpful. Thanks so much. And it's been fun doing the unit circle with you. Bye-bye.